Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph two rational functions. So I have a couple of videos on this, and so I'm just going to kind of work my way through it as kind of quickly as I can. But I will definitely also kind of make sure I explain each and every step. So we have two rational functions here. Again, we're just going to follow our 7-step process. And the first thing we want to do is identify if we have symmetry. So to identify symmetry, we're just going to evaluate our function for negative x. And if we obtain the exact same function out, then we have symmetry about the y-axis. If we obtain the negation of the function, then we have symmetry about the origin. And again, that is just helpful. It's not necessary to know, but it's very helpful because it can save you time on the sixth step. So when I go ahead and simplify here, I'm left with a negative x minus 4 divided by x squared plus x minus 6. So nor do I have the exact same function, nor do I have the negation of the function. So therefore, there's no symmetry at all. But it's just good to know. And it really doesn't take that much time. Step number 2 is now we're going to get into identifying the intercepts. So the first intercept we want to do is the y-intercept. So when identifying the y-intercept, basically all I'm going to do is plug in 0 in or x equal to 0. So I'm just going to take my function. I'm going to say f of x equals 0 minus 4, put everything in parentheses, 0 squared minus 0 minus 6. And what I get is a 4 for negative 4 over negative 6, which is a positive 2/3. For the x-intercept, y equals 0. Or in this case, we're going to use f of x. So I'm going to plug 0 in for f of x, and I will have x minus 4 divided by x squared minus x minus 6. And again, this gets every single student when we're going through this. It gets every single student when we go through this because they say, well, how do I solve for this? Well, again, to get this off the denominator, just multiply it in the numerator. And you could think of it over 1 if you like to, which is basically the reciprocal. OK? So then what's nice about that is that now multiplies to 1. That multiplies to 0. And you're left with 0 equals x minus 4. Add 4 to both sides. And therefore, our so this is my y-intercept is y equals 2/3. My x-intercept is x equals positive 4. OK, so step number 4 is to now identify the vertical asymptotes. So in identifying the vertical asymptotes, basically what we're going to do is we're going to take our denominator and set it equal to 0, because any value that makes the denominator equal to 0 is not going to be a part of our domain or of our function. So therefore, it's going to be an asymptote or a hole. So when I go ahead and determine my vertical asymptotes, main important thing here is I simplify this, or make sure also especially in this case, to determine if you have an asymptote or a hole, it's very, very important to make sure that you simplify this out. So if I was going to factor this, I would have x minus 4. What two numbers multiply to give you 6, add to give you negative 1? So that's going to be x minus 3 times x plus 2. OK, so nothing divides out, so there is not a hole. So both of these are going to represent my asymptotes. So my vertical asymptote is basically x squared minus x minus 6 equals 0. Set them both equal to 0. I'm sorry, factor them as I did. X minus 3 times x plus 2 equals 0. Then you set them both equal to 0. So you do x minus 3 equals 0, x plus 2 equals 0. And what you obtain is x equals positive 3 and x equals negative 2. So those are going to be my two vertical asymptotes. For step number 5, I want to determine what my horizontal asymptote is. So to determine the horizontal asymptote, we're going to look at the degrees of both of them. And what we notice here in the degrees is that so I'll just write down my degrees. Degree in my numerator compared to degree in my denominator. The degree in my denominator is larger than the degree in my numerator. So therefore, the horizontal asymptote is y equals 0. So now let's go to the graph. Now let's plot the information that we have. Just want to make sure that I don't know where those numbers come from. That's interesting. OK, so Now let's go ahead and plot the information that I have. So I have a horizontal asymptote at y equals 0. I have vertical asymptotes at positive 3 and negative 2. I have a y-intercept at 2/3. And I have an x-intercept at positive 4. Okay? So basically, ladies and gentlemen, again, my rule of thumb is to go ahead and determine 2 points to the left and to the right of each asymptote. And unfortunately, since we don't have symmetry, I'm just going to have to do my best with choosing points to left and right because I can't use symmetry. So a couple 2 points here. I'm going to have to obviously do 2 points to the left. I'm going to choose 1 as another point and then another one over here. So obviously, you can't choose the points where there's asymptotes because we already know those are undefined. So basically, what I'm going to look for is I'm going to want to find the points when x is equal to -1, -1, 2, 3, 4. So I'm going to want to figure out f of -3, f of -4. I'm going to want to figure out f of 1, and then 1, 2, 3, 4, and f of 5. So these are all the x values that I want to figure out. Now I need to plug in that x value into the function to find the y value. So instead of showing all that work, I'm just going to talk my way through it as best I can. And hopefully I can do it. So let's see here. Up top, if you plug in a -3 in for x, you'd have -3 minus 4, which is going to be a -7. Actually, let's use a different color. Let's use more blues. There's a blue. So that becomes -7. In my denominator, I'll have -3 squared, which is 9, minus a -3, which is positive 12, minus 6 is 6. So I have a -7 over 6. Let's go ahead and get through everything real quick, and then we'll do the rest. If I did a top, -4 minus 4 would be a -8. And then I have -4 squared, which would be 16, minus a -4, which would be positive, which would be adding 4, which would be 20. 20 minus 6, which would be 14, positive 14. Then let's do 1. 1 minus 4 would be a -3. And then 1 squared is 1 minus 1, which would be 0, minus 6. So it would be -6, so that would be a positive 1/2. And then let's do 5. 5 minus 4 is -1. And -1 and 5. 5 squared is 25. Minus 5 is 20. Minus 6 is going to be 14. OK. OK. So let's go through it. OK. Oh, the last thing I want to do is, so now to plot the points, you can see we have fractions. And we don't really like dealing with a lot of fractions. So especially plotting fractions can be very difficult. So what I like to do is take my fraction and rewrite it as a decimal. So I'd have -7 divided by 6. And that's equal to -1.2. I'm just going to approximate. -1.2. -8 divided by 14 is -5.7. -0.57. At 1/2, when I do 5 minus 4, that's a positive 1. OK. That should be corrected. So 1/2 is obviously 1.5. And then 1 divided by 14 is like 0.07. OK, so let's go ahead and plot the points as best we can. So at -4, I'm at 0.57. So very, very close to my asymptote here. And then at -3, I'm at oops, that's negative. At -3, I'm at -1.2. OK. At 1, I am at 1/2. And then at 5, I'm at 0.7. So 1, 2, 3, 4, 5. I'm at 0.7, which is like Very, very close. OK, so this one kind of comes into very difficult as far as what is going to be the relationship of the graph. Well, remember, the graph has to approach your asymptotes. OK, when you have horizontal asymptotes, it is possible for your graph to cross to a horizontal asymptote. It's never going to cross your vertical asymptote, but it is possible to graph the horizontal asymptote. But just remember, it always trends towards your asymptotes. So here, we're going to graph those. Here, you can see I kind of have another little parabola thing going on where, again, they need to approach the asymptotes. So that's going to look something like this. And then here, it says it crosses at 4. And that's possible for it to cross at 4. It has to approach this asymptote. And then if it crosses, what we kind of do is like a little hump here. And then it continues on approaching the horizontal asymptote. So even it's going to cross, but then it's going to continue approaching it in that direction. All right? All right, so now let's go and get into this example. So I have x minus 3 divided by x squared minus 9. Now, quickly, I know I can factor x squared minus 9 to x minus 3 over x minus 3 times x plus 3. So it's very important for us to notice that now we are going to be dealing with a whole instead of also a asymptote. So just make sure that we have that information at 74. OK, so now let's go and check symmetry. So it's symmetry, again, f of negative x. When I do that, I get negative x minus 3 divided by negative x squared minus 9. That equals negative x minus 3 over x squared minus 9. Doesn't prove the negation or the thing. So again, we have no symmetry. Step number 2 is finding the x-intercept or the y-intercept. So y-intercept, x equals 0. So I'll basically do f of x equals 0 minus 3 divided by 0 squared minus 9, which equals negative 3 over negative 9, which equals 1/3. So therefore, my y-intercept is at a positive 1/3. Cool. Next one is going to be the x-intercept. That means y equals 0. And again, our y, we're using the f of x function as our dependent variable. So therefore, I'm going to plug 0 in for f of x. And then x minus 3 divided by x squared minus 9. Again, to solve for x, I'm simply going to multiply by the reciprocal on both sides. That goes to 0. That goes to 0. 0 is x minus 3. When you go ahead and solve, you get x is equal to 3. Step number 4 is identifying the vertical asymptotes. To determine the vertical asymptotes, again, basically all we're going to do is set our denominator equal to 0. So I have x squared minus 9 equals 0. I've already simplified this because I wanted to check for holes. So therefore, we're still going to factor it the same way. X minus 3 times x plus 3 equals 0. But since x minus 3's divide out, so when we have x minus 3 equals 0, and x plus 3 equals 0, this is going to be your whole. This will be your asymptote. So when you add, you have x equals 3. And when you subtract, you have x equals negative 3. Again, this is the asymptote. That is the whole. Last step we want to do is determine the horizontal asymptote. To determine the horizontal asymptote, we're going to look at the degrees of our numerator and our denominator. So we can say that our numerator is less than the denominator of the degree in our denominator. When that is the case, just like over here, we have y is equal to 0. OK? So now let's go and plot the information. I got a nice little pocket right here. All right. So the first thing is we know that we have a horizontal asymptote at y equals 0. We have a vertical asymptote at negative 3. And we have a horizontal asymptote at positive 3. Now, we don't know what the y value. We don't know what the y value is at 3. So, or where the graph would be at that point. So I'm just going to kind of put a hole there. But I don't know where. The graph could be up here. It could be down there. But wherever x equals 3 at that point, it's going to be a hole. And I'll show you how to do that here in just a second. So now we basically just need to pick 2 points to the left and 2 points to the right of this graph. Now, when looking at this, the main important thing is I would probably say just pick 2 points that are really close to the asymptote. Those are usually the best to pick, even though 3 we know is going to be way over there. But then we can at least get a kind of general shape of the graph. So I'm going to want to find the x values for -1, -2, -4, and -5. So I'm going to do f of -1, f of -2. F of -3 is an asymptote, so -4, and f of -5. OK, so f of -1, when I plug in -1 in for x, I get -1 minus 1, which is -4, over -1 squared, which is +1. +1 minus 9 is going to be a -8. So that gives me a +1/2. OK, let's do -2. When I go ahead and go through -2, I have -2 minus 3, which is a -5. And -2 squared is going to be a +4. +4 minus 9 is going to be a +4 minus 9 is a -5. Oh, so that's a +1. Now let's go into -4. At -4, let's see, we have -4 minus 3 is a -7. And -4 squared, which would be 16. 16 minus 9 is going to be 16 minus 9 is going to be a +7. And let's do -5. -5 minus 3 is a -8. And -5 squared is going to be 25 minus 9 is going to be a +16. OK, so now we just go ahead and plot our points. So at -1, I'm at 1/2. At -2, I'm at 1. At -4, I'm at -1. At -5, I'm at -1/2. OK, so you can see here, again, they need to approach the vertical and the horizontal asymptotes. So I'm just going to do some nice little hyperbolas here. But just remember, when I get to here, 1, 2, 3, I'm going to do a circle. Because at 3, remember, that's a hole. So when you're graphing your hyperbolas, graph it, but just make sure you also include an open circle at your hole, because the x value is not a part of the graph at that value. So there you go, ladies and gentlemen. That is how you graph rational functions with a hole. Thanks.